Hello. In this video, we'll be digging deeper into our CCAux functions, which I've created a basic video on. So if you haven't seen that one, please go check out that video first, as it gives you a good base for what CCAux is. But essentially, it's our access to the display's hardware. So things like the configurable I/O, the buzzer, the buttons, any boot up processes, or how to start up or shut down the display, you can access through CCAux. So in this video, we'll actually be looking at how to integrate a CCAux function into your Qt applications. So to start us out here, I have our virtual machine open, and this is just the virtual machine we've been using for all these videos, and I've opened Qt. So I'm going to go ahead and create a new project here, and we could create a widgets or a QML project. In this case, I'm just going to do widgets. It doesn't really matter. We're going to interface with, I think, the buzzer in this video so you can hear it working, and I'm just going to call this buzzer interface. There we go. I'm gonna just make this a Qt4 and Qt5 ARM development, since I'm using a VC right now. So I'm gonna go ahead and hit next, finish. Okay, so we have a blank project here. Let's first take a look into the .pro file, because this is where we're gonna find some base files that is good for you guys to understand where we're getting things. So all of this is kind of generic .pro file stuff, but here you'll see the Maximatech specific libraries. And if we look into the Qt4 and Qt5 ARM builds, we will see include paths in here. And these are our include paths, which have the header files that we'll be interfacing with. And these are the same header files that I talked about in the last video. So if we quickly open Chrome here, and I look at our support site, and I'm going to go to the VC display page here. So display computers, VC is where I'm at. I come to manuals and look at the CCAux manual, which we were looking at in our previous video about CCAux. I'm going to go down to page 12. And here are all the header files. So all of these files are what is in that include file path. So if I look at buzzer, I can see the different functions, and we looked at these and talked about these and how to see them in this file. So now if I come back to here, I can see my include file path is opt.exe include. So let's take a look there. So if I come to opt.exe include and say I do a search for buzzer, well, nothing. Let's see. I needed to say capital B. Let's try that. And there we go. So buzzer.h. So if I even open this file, we can see our, and we'll see this from Qt as well, but we can see our header file here, and it is the same as what's described here. So get buzzer, get frequency, and we have those functions in this file. So here's the get buzzer, buzzer release, the get frequency. So as we talked about before, this CCAux file essentially just goes over or looks at all of the different header files and functions available to you, which we can also see in our development platform. So lastly, the libraries. So we have our headers, and then we have what's called shared objects in Linux, which are essentially libraries. and our library path is identified here. So all of the CCAux libraries are actually included in just a few shared object files. So if we go optxa user lib, so user lib here, we can see we have a lot of shared libraries, so you can check which ones. We're going to say ls-la lib cc-aux. I happen to know that's the name of the library files. And we can see here that we have the CCAux library 283 that we're using. And this correlates again to what we talked about yesterday with the version of CCAux that we're using here. So we can see 283, and in our virtual machine we have CCAux 283. So if you're using a different version, so let's say you're using the XA display and it's using 2.7 something, you should see the 2.7 something here. So, and like I said, the libraries are backwards compatible, so even if you're using 2.7 and you have 2.8.3 identified here, you might just need to pull the libraries off of the display. So I'll probably go over that in a different video, but you know, here is where the libraries are. So you can see I have 273 here as well, but we would need to repoint these symbolic linked objects to 273. So I will do that in a separate video, but you essentially should be matching the version of the libraries here, 283, with the ones that you have installed on your display. And you can check what is installed on your display by logging into the display. So I'm going to say sh root at the IP address I'm using, .2.21. And right now I'm using a VC display. And I think actually this display will have, I'm using an updated OS and engineering version. So it's going to actually have an updated version of CCAux, but the concept will be the same. So if I go to cd user lib and I do the same thing, ls-la lib cc-aux. So here I can see the CCAux files I have installed on my display, and you can see it's a different version, so 3.290. So this shouldn't be a problem because what I have installed on my display is a later version than what I'm using here. So as I said, it's backwards compatible, so everything should still work. Using 283 in my virtual machine and 2.9 on my display. But if I was using 283 here and 2.7 on my display, then I might run into issues. So essentially, you should just try to make sure that the versions that you have installed in your virtual machine and your display match. If you're running into problems with CCAux, that could be a good starting place if they don't match. Okay, so now that we've looked at what our library paths and include files mean, that's actually, so the include path will come in, will I think make more sense as we include the different header files, because this path is where it's going to look for these header files. So let's get started on actually integrating the buzzer in. So we're going to come to our header file right here, and we're actually going to include the buzzer header file that we need. So if we want to work with the buzzer, we would include the buzzer. If we want to work with video, we would include video. So as I said in the previous video, all of those, the different generic header files are outlined here in the CCAux document. So definitely take a look at this and figure out what you would like to interface with on the display and where those functions are, and you'll have to include the appropriate header file. So in our case, we want to work with the buzzer, so we're going to include this buzzer.h header file. And once we do that, we can actually right click on it, and so it's, and say follow symbol under cursor, and this will actually show us or take us to the header file itself. So all of the CCAux files are laid out in a similar manner, so interfacing with each of them is going to be done in a very similar way, which is why I'm only going to do one of them. And I'll point to some other examples on the support site later on. But in this case, we're going to create a buzzer handle, and we can see down here that a lot of the functions use this buzzer handle. So the get frequency, get volume, set volume, all of that. So everything uses this buzzer handle. So, and you can kind of look at what the functions are, and in this file they give a brief description. Frequency, the current frequency, it gives you 700 to 10,000 hertz. It also tells you, as in with this file, it'll tell you, because we have many different displays and not all of them. For instance, like if we come to config in.h, so our X series displays don't support configurable inputs or outputs. So what we should see here is the VC and VA platforms are the two that support it. So you'll have a note here about the supported platforms for each function. So for instance, if you're trying to use this on an XS, it won't work because that is not part of the supported platforms for this function. So we can also see that here, supported platforms. And in this case for the buzzer, all of our displays have a buzzer, so all of them are supported. And even though the VA isn't in here, I don't know why, but it's also supported. Okay, so let's come to our header file again and just create a buzzer object. So we're going to, and actually, sorry, one last note. If we come back here, we'll see it's using namespace CrossControl. So we are going to, we could include our namespace CrossControl, but in this case, I'm just going to call it out specifically. So CrossControl buzzer handle, and I'm going to call this buzzer, how about? Okay, so we've now created our handle, and I'm going to now come into our application.cpp, and the first thing we need to do is initialize our handle. And to do that, we're going to use CrossControl, and I think it's called, we can go back in here, and so we create the handle, and then we have to initialize or get the handle. So and it tells you that here, so it allocates a buzzer object. So we're going to use this get buzzer function, and then once we have that and it's allocated an object to our buzzer handle, we can use any of the other functions that we see here. So we're going to use this get buzzer, and to do that we're going to set our buzzer object that we created here equal to that, and now we have our buzzer object or handle, and we can use any of the other functions. So for instance, let's look back here, and I happen to know a few functions, but we can see this last one, buzzer buzz, takes in the buzzer handle, a time, and a blocking function. So we can see what it does up here, but it essentially will turn on the buzzer for the time you set in milliseconds. Blocking will it block the display from doing anything else while this buzzer is going off, or not block other functions from executing. So in this case, we'll just make it not blocking. We'll set it off for 1 second and confirm we actually hear it. So let's call that. So we're going to say CrossControl buzzer buzz, and the first thing we need to do is pass it our buzzer handle, which is buzzer. The second thing is our time, so in milliseconds, so 1000 is 1 second, and blocking, and we're gonna make it non-blocking, so false. Okay, and we haven't modified our application at all. I think I have a program running on the display, so I'm just gonna kill that. All right, so let's try this out. Go ahead and build it. Should hear the buzzer go off and if it deploys correctly. Right. So sometimes you will actually, I've seen these errors before. It says the remote file system. That's actually because if I come to my projects tab and run, it's because it's checking for free disk space here as part of its deployment, and it's checking the root directory of the display, which sometimes, depending on how much you have installed, may be filled up. And really, you want to be checking the user directory. So we want to check /opt for that, or you can just remove it altogether by just eliminating it as a check there. So let's try that again. And that was the buzzer. So everything appears to be working. What happened is it's just we put this code in our initialization. So as soon as the application starts up on the display, it's going to set the buzzer off for 1000 milliseconds or 1 second. So let's do one. This is semi-useful, but we could, of course, for instance, add a push button here. We'll call this buzz, and we're going to just add a clicked function, and we're going to bring this code or just copy it down here. And there's other things we can do with the buzzer. I'm not going to go over all of them, but I mean, you could, for instance, set the time, or not the time, the volume by, let's see, looking, set frequency, so we can set the frequency or change that, or set the volume. So it tells us the volume is between 0 and 51. So we could, for instance, come here and nope, can't type today. Buzzer set volume here, and let's make it the loudest that we can. I think we need to actually see if it tells us. Yeah. So it takes in the buzzer handle and then the volume. So we need to give it the buzzer handle, which is buzzer. And then the volume will make it the loudest, so 51. So let's do this again. So now that's when it initialized, and I'm going to press the button, and we can hear it buzzing as the button's pressed. There's other things, I could set the volume lower to say 10, and we should hear the it be much lower now. So that was the initialization. And I don't know if you can hear that, but it is pretty quiet, but I can hear it. So yeah, so I mean, there's a lot of functions that we can do with the buzzer, and obviously that's only the buzzer that we're looking at right now. If we look in our CCAux document again, back on page 12, we have a lot more header files that we can access and modify the hardware. So, you know, PWMs, configurable inputs, video, the button LEDs, the front LEDs on our XA and XS, our X series platform. So there's a lot you can do. As I said in the previous video, I would recommend looking over this document and at least getting familiar with some of the functions that you're able to use. And all of them pretty much work in the same way that we've set up here. So in our code, we've created a handle, in this case a buzzer handle. We've assigned or initialized this handle to initialize the object, the buzzer handle object, and then we use that handle in the functions. So every CCAux function is pretty much going to go off of the same idea. So if we look at, for instance, the digital I/O, here we have the digital I/O handle, and we can get the values of the digital I/O by passing in the handle and then this unsigned character status, which is going to return ones and zeros for each of the digital I/O we have set, and we can also set it. So it, you know, also tells you the digital inputs here. So on the X series displays, there's 4 inputs or outputs, so they can be set in different ways, and that kind of goes over that. So all of our functions are pretty much set up the same. So just like we set up the buzzer is how you would interface with any of the hardware functions on our displays and any of the header files. So you just need to include the header file that you want to work with, create a handle, initialize or create the handle object, and then use the functions. Okay, I think that pretty much covers this video, and probably closes out CCAux. Oh, lastly, I'll say if we come to our knowledge base here, so I'm back at our support site, and there are several examples of using CCAux in our knowledge base. So for instance, there's an example about using the configurable I/O on the VC and VA displays, and this has a code example, and that is going to use CCAux. There's an analog video example, which is going to use the video CCAux. The buttons don't, the hardware buttons actually don't use CCAux, but there's an example there. So I would recommend going through the knowledge base as well and checking out, you know, if you have a specific piece of hardware that you'd like to interface with. We may already have an example posted on the knowledge base, but if not, some of the examples posted can help build on this video. So please go check out the knowledge base. Okay, I think that does it. Thanks for watching, and tune in for other videos. Thanks.